Today we're going to talk about binomial expansion. You remember much about this?
No, not really. That's why I came.
All right, so let's just do this then. So, um, this formula is on the formula sheet, but it's kind of confusing to look at. So what they want is they want the first three terms of this expansion, and so I mean if this was only 3 minus 2x squared, well that wouldn't be a big deal because I could multiply that. If it was to the third power, well, that probably wouldn't be a big deal because I could square this and then multiply it by that, and it'd be a little bit of work, but I probably could do it. But when it starts getting to the fourth, fifth, sixth, seventh power, it gets really complicated. And there's this shortcut kind of formula that we can use to do this whenever we're taking a binomial and raising it to a power. So first, what we're going to do is it's going to be a combination of the power and the first term. And keep in mind, it always starts with a 0. And then what we do is we have this first number, and then we have the second number. And in this case, what happens is that this 0 and this power are always the same. And then these two always add up to the top number. So this has to be 5. So what happens is 5 choose 0 is going to be 1, and anything to 0 power is going to be 1. So really I just need to know what 3 to the 5th power is. What's 3 to the 5th power?
243.
243. All right, now that's the first term. Now notice how they say do it in ascending powers of x. My experience is that typically you're not going to have to do anything weird in order to make that happen. They're only saying it in this case because typically we write polynomials in descending order, going from the biggest power to the smallest power. Here they're saying you're going to go from the smallest power to the biggest. And so what you can do is always kind of do a quick check. These are going to be the same, only now that this is a 1, this power over here is going to be a 1, and this is going to be 4. Now notice, even just before I go and figure all this out, that this is going to be some number to the x power. And when I do the next one, whoops, not 4. This is going to be to the second, and so this is going to be to the third. But do you notice how just looking at this is going to be a number to the x to the first, and then this is going to be a number x to the second. It is going in ascending order. So anyway, this is going to be 5 times 3 to the 4th times negative 2. What's 5 times 3 to the 4th times negative 2? You got it? You got it?
Uh, I got
What's 5 times 3 to the 4th times negative 2?
I got negative 810x.
Negative 810x. Because you notice this is x, right? All right, so then I don't know what 5 choose 2 is. What's 5 choose 2?
10.
So this is going to be 10 times 27, right? 3 to the third, 27.
Yeah.
Now here's where you have to be careful. This negative 2 is to what power?
2 to the second.
So what's negative 2 to the second power going to be?
4x squared.
Right, it's going to be 4. And see, right now, I just worried about the numbers. So this is going to be 10 times 270, or 227. So that's going to be 270. What's 270 times 4?
1080.
And then you're right, it'll be x squared, right?
Mm-hmm.
Where people mess this kind of thing up is they try to do it fast, and then they forget about this negative 2 being to the second power. And so sometimes they do 2 times 27 times negative 2, or sometimes they do 10 times 27, and then for some reason they get this to be negative 4. But more often, they remember to take the x to the second power, but they forget to take the negative 2 to the second power. And so the number gets screwed up. Anyway, do you see how these are the first 3 terms?
Yeah.
All right, so that's the answer to A. And I could write it like this, or particularly it would be written as a polynomial of 243 minus 810x, and then plus 1080x squared. Okay? This is a formula. Let me see if I can find it. I should just get a formula sheet. This is a syllabus that says everything we need to teach and you need to know. But what happens is it's more than just our class, and so that's why it's so long. All right, here's the pure math. All right, so take a look. This is the formula for a binomial series. And again, it is going to be on the formula sheet, but the way it's written, it's kind of cryptic. The reason this is a to the n is because you'll notice when we did this, these 2 terms ended up being nothing. This ended up being a 1, and this ended up being a 1. And so this is that first number to whatever this power is. So in the formula, they don't put these pieces on here because they're always going to be a 1. And so this is going to be a to the n. And then you'll see n choose 1, and then you'll notice how this is always going to be a to the power. These are going to match. See here how this is a 2, and this is a 2, this is a 3, and the outside's a 3. So the problem is that the formula isn't as complicated as that makes it look. And if you don't know it, it might be a little bit of help to jog your memory, but it's not awesome. So anyway, that's part A. That's the answer to part A. Now, what they love to do then is they love to have you find a particular term in a particular power, not everything. And they want us to do is they want to multiply what we just found. And again, they only had us find 3 terms because that's all I need to do to answer this question. So, don't think you've got to do more. If they have you find 3 terms, it's enough to answer, usually. I guess I can't say that for everything. Now, what they want to multiply by is 4 plus x squared. So what we're going to do is we're going to multiply this times 4 plus x squared. We're going to multiply this times this. So what do I got to do to 4 plus x squared before I can multiply those 2 together?
You have to expand it.
Yeah, so what is 4 plus x squared?
16 plus x squared.
What else?
And plus ax.
Good. So really what I'm doing is I'm taking this times, remind you there's more terms, we just don't have them all, right? I'm taking this times this. Think of it like FOIL. If I was doing x plus 1 times 2x plus 3, I would multiply everything times x, and then I would multiply everything times 1. If I was doing x plus 1 times x squared plus 3x plus 4, I would do everything times x, and then everything times 1, and I would combine like terms. You get what's going on here?
Yeah.
All right, so the thing is, though, I don't want to do any more multiplying than I need to. So all I care about are terms that are going to end up being x squared. So if I multiply 16 times 243, is it going to be anything x squared?
No.
And if I multiply 16 times negative 810x, is it ever going to be x squared?
No.
What's the only thing I can multiply by 16 by to get something x squared?
1080x squared.
So I'm only going to do this multiplication. All right. Now, I also have to multiply everything by this. Now, once again, I should, if I was doing, if I was actually finding the product, I would multiply everything over here times 8x. But there's only one number out of these three that if I multiply times 8x, it's going to end up being x squared. What number is that?
Negative 810.
So, in this case, I'm going to do plus 8x times negative 810x. And then I would multiply x squared times everything over here. But once again, there's only one number out of these numbers that is actually going to end up being an x squared. What's that?
243.
So that, and we could figure that one out pretty quickly. That's going to be 243x squared, yes?
Yeah.
So now, do these other ones. What's this? What's this? And then add them together and tell me what you get.
I got 11,043.
And so it's going to be, and like if I would have done all this, it would have been 11,043x squared. Technically, the question asks for the coefficient. I would probably say that the answer is 11,043 because that's a coefficient. Yeah? You with me on that?
Yeah.
All right. So what happens is that this is worth 3 points right here. And you've got to do this. And see, if you know this pattern and these things, it's not that tough, okay? Now, this is actually less work to get these other 3 points, but it requires more thinking. And if you just do the 3 multiplications that you need to do, well, then you can do this pretty quickly. But you've got to do some of these problems in order to get the sense of what's happening here. So anyway, let's take a look. And the rubric, again, there's not much playing around for this first one. You either give them these 3 numbers or you're getting no points. Okay? There's no method points for doing this. They expect that you can take, because they give you the formula, they expect you to be able to use it and come up with these 3 numbers. And, I mean, where do you think people screw up? Like I said, adding, subtracting, multiplying, I mean, doing it quickly, and that's where they make a mistake here. Most people can set this up correctly, and then they lose track of the square or some negative sign, and then the numbers get messed up. But anyway, that's what they're looking for. They're only looking for those 3 numbers and those 3 points. And then here you can see where you get a point for changing this to this. So you should show it. I mean, not that you would probably do it in your head, but you should show it. And then, again, you'll notice how they've got these 3 things which those are the 3 multiplications that we did, and then they ended up with the one number. Now, in this case, you will notice that if you had just written 11,043x squared, they would allow that. But, I mean, that's what they're looking for. So in this case, you can get a method point for doing this part, for you actually multiplying the correct things. Say you multiplied them and you got the wrong number, you could still get a point. Say you got the right idea and you just push a wrong thing, and so, you add, subtract, you do something wrong. But if you show them you're doing this, and see, that's another thing. You could have done this entire thing in the calculator. And if you did do the entire thing in the calculator, and all you did was spit out one number, and it isn't the right number, then you're not going to get the method point. And in fact, if you do get this right number, you may still not get this method point. They need to see something about what you're doing. All right, questions about that?
No. I'm good.
All right, so this one's a little bit different, because you notice what happens is we've got a couple things. Number one, you notice how I've got x in the denominator? What do I got to do about that?
You have to put it up, or you want to put it up next to the 10.
Exactly. So what's it going to turn into? This is going to become what?
It's going to become x to the power of negative 1.
Exactly. So this is going to be plus 10x to the negative 1 to the third, right? Now,
Yeah.
It says the coefficient of x in the expansion, this, is p. So basically we need to find the coefficient of x. Okay, and we're going to call it p. All right? And I guess we're going to do this thing here. All right. So then it says the coefficient of 1 over x. So what? Here, let's write this. Oh, can we fix this one too? How do I fix that one? 2x is fine. What's the other one going to, what's this other term going to be?
Kx to the negative squared.
Exactly. Okay? Now it's still going to be the fifth. Now here, what term do I want? Rewrite that one.
X to the negative 1 power.
Exactly. Okay? So for this one, I need to find the coefficient of the x term. And for this one, I need to find the coefficient of x to the negative 1 power. And then I'm going to call that, so this one we're going to call p. And this one we're going to call q. Okay? So, first, and again, I'm not too worried about this second part here, because I clearly have to find these first two things. So that's what I'm going to do. What should I write down? What's the combination going to be?
3, choose 0.
Well, see, here's the trick. Because I only wanted, I could do a bunch of terms and try to find the one that has the x, but it's a lot faster if we just do one term. So let's try this. What's the top number going to be for my combination?
3.
All right, and what's this first thing in the parentheses going to be?
4x.
And then what's the second thing in the parentheses going to be?
10x to x to the negative 1 power.
All right, now here's what I know. I know that this and this number are going to be exactly the same, yeah?
Yeah.
So what I'm going to do is I'm going to call those r. Now, I know also that this right here is going to be 3 minus r. Does that make sense to you?
Yeah.
All right, because these two numbers, these two powers, always have to add up to 3. So, for example, if this was a 2, the r was a 2, well, then this number over here would be 3 minus 2, or 1. Yeah? All right, so if, and I'm going to rewrite this here. Ignore what I'm about to do. Here, I'll do it in green. All right, so what if this looked like this? What if it just said 4 plus 10x to the third? If I was doing that, this would be a 3, this would be a 4, and this would be a 10 and x, right? Now, wouldn't it be pretty easy to figure out what the powers would have to be to find out the x term? What would this power have to be?
Ooh,
I want to know the x term. So don't I want to make this to the first power?
oh, yeah.
And if this is to the first power, what does this have to be?
0. Well, no, 2. Yeah. Well, no, 3. Yeah.
Oh, no, you're right, 2, right?
Yeah.
And if this, that's got to be a 1. If there's only one x out of the two things, then it's pretty easy to figure out what this power has to be. If I want the squared term, then that's got to be a 2. If I want the cubed term, then this has got to be a 3. If I want the -1 term, then this has to be to the -1. Does that make sense?
Yeah.
All right. The problem we have is that I've got two variables, and it's not quite so easy to figure out what they are. Now, you could guess, because typically the powers aren't that big. You could try a number here, and try a number here, and then try a number here, and try a number here. But what we're going to do is I'm going to take these two exponents. Right now, this is to the first power, right?
Mm-hmm.
So what's 1 times 3 minus r?
3 minus -r.
Well, 3 minus r, right?
Oh, 3 minus
Yeah. Now, what's -1 times r?
-r.
All right. Now, so what I'm doing is I'm making an equation out of these powers, okay? And when I put them together, I want them to equal the number 1. Does that make sense?
Wait, so you're going to equal to 1 because 1 is going to have the x, right?
Because between these two, I want their when I multiply them together, when I take two polynomials or binomials, for example, if I did 4x to the second times 2x, well, here, let's put this on the inside. If I multiply these two together, what am I going to get? What's 4 times 2?
8.
And what's the x is going to be?
X to the cube.
And how'd you get that?
You added the exponents.
All right, so here's what's happening. I'm multiplying this times this. So what am I going to do to their powers?
You're going to have to add it.
And when I add them, what do I want to end up with?
1.
And that's where this comes from. Does that make sense?
Yeah.
This only makes sense if I have two things, but I need them to come up with the power of this. You with me on that?
Mm-hmm.
All right. So now that I know that the r is a 1, this is going to be 3 choose 1, because that's what r is, right? This is going to be 4x, and then it's going to be not to the 3 minus r, it's going to be 3 minus 1, or 2. And this is going to be 10x to the -1, all to the first. You with me?
Yeah.
All right. Now, 3 choose 1 is what?
3.
And 4 to the second power is what?
16.
So what's 3 times 16?
Is that try to 48, right?
48. Good. Now, I'm going to multiply that number times this 10, because this 10 is to the first power, right?
Yeah.
So what's 48 times 10?
480.
All right. Now, look at this. This is going to be x to the second, right?
Mm-hmm.
And what's this going to be?
10 to the x -1 power.
Well, it'll be x, but the point is it'll be x to the what?
-1 power.
Now, when I multiply those together, what's it going to end up being?
480x.
And that's what I'm talking about, right?
Yeah.
So what's my coefficient?
480.
All right. Now, that's P. Okay?
Mm-hmm.
Now I'm going to do the same thing over here. Here, I am going to write the combination, which is 5 choose I don't know. And the second one's going to be 2x. And the next one's going to be kx to the -2, right? So again, you notice how I have x's in both of these two spots? That's when I use the equation. So I'm going to say this is r, this is 5 minus r, Okay? And then again, this is clearly 1 because I'm going to multiply the 1 and I got to multiply this right here. So what's 1 times 5 minus r?
5 minus r.
Yeah. And then what's negative 2 times r?
Negative 2r.
Now, again, when I multiply those two terms, I'm going to add the exponents. In this case, what do I want to end up with?
X to the negative 1 power.
So I want to end up with a negative 1 power. Yeah?
Yeah.
So what's r equal to?
Minus 3r.
So I got to get this all on one side, right?
Mm-hmm.
Minus 2r. Now subtract 5. So what's negative 1 minus 5?
Negative 6.
What's r going to be?
3.
And see, again, in both these cases, do you notice how the r is not a very big number? Did I do this one right? What we say?
You're supposed to my English, negative r minus 2r, right? Aren't you supposed to do that?
Oh, hang on, let me see here. Minus 2r, right?
Yeah.
So, okay, so we didn't finish this. Oh, duh. All right, so let's take a look at this. What's negative r minus 2r?
Negative 3r.
Negative 3r. And then when I subtract 3 on both sides, wait a minute now. What do I get? I got 2 r's, don't I? Hey, now I messed up. This is a 1, right? Come on. Is my pen not doing it? All right. So 3 minus 2r equal 1, right?
Yeah.
3 minus 2r equal 1. So then when I subtract 3 on both sides, what do I get?
Negative 2.
And see, do you see when I solve this? I don't know why I skipped over solving this. But do you see negative 2 divided by negative 2? R is going to equal 1.
Yeah.
All right. In both these cases, this r equal to 1 and this r equal to 3. Like I said, if you wanted to, you could try this. Put a 2 here, put a 1 here, 3 here, 0 here, and see which works. But the equations make it a little quicker. All right, so let's do our thing now. This is going to be 5 choose 3. This is going to be 2x. And this is going to be kx to the negative 2 to the third power. And if this is to the third power, this needs to be the second power. Yeah?
Well, Mr. Cross, is that supposed to be negative 3r equals to negative 6?
Negative. Because I only have 2. Oh, wait a minute. Where did that come from? This is 5 minus r. And then this is minus 2r, right?
Mm-hmm.
So, yeah, you're right. Negative 3r. Oh, duh. Thank you. So this should be negative 3r. So it should be a 2 then, right?
Yeah.
Oh, my gosh. Thank you. So let's fix this. So that makes this a 2. That makes this a 2. And that makes this a 3. Yeah? All
Yeah.
right. So now let's take a look at this. What's 5 choose 2?
Oh, 10.
10. And then what's 2x to the third?
Ax cubed.
And then what's kx to the negative second squared? Start with the k.
K squared x.
So it's going to be k squared. And then when I do these, what am I going to get?
Oh no, you get it'll cancel out, right?
Well, no, because I multiply them. When I raise a power to a power, I multiply.
Oh yeah.
So what's this going
-4.
to be? X to the what?
X to the -4.
All right. Now notice. Well, first, what are my coefficients?
8 and k squared.
All right. So what's 10 times 8?
80.
80 times k squared.
80k squared.
Okay.
X.
Now that's my coefficient. Now notice, if I multiply this times this, and I add the exponents, what am I going to get?
X to the -1 power.
Which is what I want. Does that make sense?
Mm-hmm.
Now, they told me to make that equal to q. Now that we figured that out, let's see what this says. It says that if p equals 6q, find the values of k. So what they're doing is they're giving me a way to make it an equation. So let's do this. P is this. P, I'm going to write this down. P equals 6q. P is equal to 480, so I'm just going to replace it. Q is equal to 80k squared, right? So I'm going to replace that. And see now, what do I got to do? They've given me this tool to make an equation. What can I do?
Multiply 6 by 80k squared.
Yeah, well, what's 6 times 80k squared?
160k squared. No, wait, 480k squared.
480k squared. So then what do I do?
You'll divide by 480.
Because notice I'm trying to get k right at this point, right?
Mm-hmm.
So if I divide by 480, divide by 480, I get 1 equals k squared. Now what do I do?
You square both sides.
I square both sides? If I square k squared, I'm going to get k to the 4th.
Oh no, square root.
Right, right. So if I square root this and square root this, this is going to become a k. What's this going to become?
Positive or -1.
Exactly. And you can see, or I'm guessing, I hope you know that the common mistake here is to forget the plus or minus. Whenever you square root both sides, make sure you make one of the sides plus or minus. Okay? So, that looks kind of messy. We'll do another one. You got questions about this, though?
Yeah, I feel good about it. It's just that I gotta remember that R thing.
Yeah, I know. Like I said, just keep in mind that basically what I'm doing is I'm going to multiply this times this, which means I'm going to add their exponents, and I want their exponents to add to a particular number. I make an equation out of that. Now here's a rubric. Okay, so number one, for this first part, they want 480 to be a P, and I mean, there's no real method point. You need to be able to get that. Okay? Then what happens is that we do this K. Well, you notice how we've done this 10 times 2x to the third times K. So again, you can see where we did this multiplying here. That's this. We can get a method point for that. Then we get this 80k squared. We can get that point. And then the method here is to set up this equation. So if we set up this equation, we can get a method point. And then you'll notice that they need the answer to be k is equal to plus or minus 1. Now, it says don't give them any credit if there's a range of values, which I'm not really sure why somebody would do that, but if they've got it on here, it's because people do it. And that you shouldn't leave it like this. So, anyway. This seems like it's going to be similar. Let's try this one. What does it say for the first one? Write down the first 4 terms of this expansion. Tell me what to do.
You'll set it up. So first you'll do 6 choose 0.
6 choose 0.
Then you put A.
What else am I right?
Negative X.
And then what?
A would have the power 0 and X would have the power 6.
In this scenario, and see, here this makes it a little confusing. You know the binomial distribution that we're working on right now?
Yeah.
These two will have the same powers. But in this, these two will have the same powers. It's not exactly the same.
Okay.
Okay?
Mm-hmm.
And you can see how that's going to be confusing. Now, the good news is that this is on the pure math test and the other one's on the stats test. So if you're getting ready for the pure math test, you kind of straighten up your mind and you make sure you're straight with this. But yeah, they are very similar in the setup. The only difference is this is going to be over here. So then what's this middle one going to be?
It would be 6.
Yeah. And then what's the next one going to be?
6 choose 1.
And then what?
A5. And then 1.
And then what's the next one going to be?
6 choose 2.
Yeah. And see what happens is you can see that it's going to develop a pattern. And see, the reason I like writing it in a column like this is because the pattern is really easy to see. On the formula, it has you writing it sideways. And if you get your pattern off track, it's harder to see. When I write it like this, 0, 1, 2, 3, 6, 5, 4. Whoops, see, I did screw up. This should be, no, I guess I didn't. It's still a 3, right? 6, 5, 4, 3. Did I put 4? Anyway. All right. So then we got to figure these out, right? These first couple aren't that hard because 6 choose 0 is 0 and this is 0. So what's this first term going to be?
A6.
Yeah.
A to
And this is going to be 6. And this is going to be a to the 5th. This is going to be 6. This is going to be a to the 5th. And this is going to be negative x, right?
Mm-hmm.
So what's the number going to be?
6, 8 fifths, and then negative X.
So it'll be negative 6.
Oh, yeah.
Right?
Mm-hmm.
A to the 5th, right?
Mm-hmm.
And then x, right?
Mm-hmm.
All right, now this one we got to do. What's 6 choose 2?
$15.
So that's going to be 15 times a to the 4th, and then this negative 1 is going to be squared. So what's negative 1 times negative 1?
Positive 1.
All right, so this is going to be 15 times a to the 4th. Come on. And then this is, the letter is going to be x squared. Yep.
Mm-hmm.
And then this, what's 6 choose 3?
20.
20 times a to the 3rd times negative 1. Now, negative 1 to the 3rd is negative 1. So this is going to be negative 20 a to the 3rd x to the 3rd. Yeah?
Yeah.
All right, so we just did A, that's right, the first 3 terms. Now you'll notice that this wasn't particularly a difficult thing, and that's why compared to the other one, it was only worth 2 points. But, I mean, it's not too hard for 2 points. Do you agree?
Yeah.
All right, so now what do they want me to do?
Given the coefficient of x squared, the expansion of 1. Oh, yeah. Given, yeah. They want to find x squared.
We're going to multiply this times this. Yeah?
Mm-hmm.
So what is this going to change into?
1 plus 2ax to the negative 1 powered.
Is the a going to be in the numerator or the denominator?
The denominator. Wait, no. It'll be in the numerator, right? Because it's together, or no?
So what's going to happen is that the a is going to stay down there.
Oh, okay.
Say, for example, if I wrote this, 1 plus 2 over 3x. All right, I got to fix the x. That's the problem. What has to go up to the top?
The x.
Just the x. So that would end up being 1 plus 2x to the negative 1. Whoops, negative 1. But it'll still be over 3. Okay?
Mm-hmm.
So that a is a number. We just don't happen to know what it is. So what's going to happen is this is going to be 1 plus 2x to the negative 1. But what's it going to be over?
A.
You with me on that?
Yeah.
All right. So now what I'm going to do is I'm going to multiply that. So I'm going to write this out. A to the 6th minus 6a to the 5th x plus 15a to the 4th x squared minus 20 a to the 3rd x to the 3rd. And I'm going to multiply that times 1 plus 2 over a x to the negative 1. So first, and what term do I want?
X squared.
So I'm not going to multiply everything by 1. What's the only one I care about?
The one that gives you x squared.
So what's that going to be? What do I multiply 1 by?
15 or 15a. Yeah.
Those two get multiplied together, right?
Mm-hmm.
And 1 times that. So that's going to give me 15 a to the 4th x squared. Now I'm going to multiply this other thing by something. I'm going to multiply this by something, and I want to end up with x squared. So what am I going to multiply it by?
The one with the coefficient with negative 20.
So I want to multiply it by this guy because it's x to the 3rd, right?
Yeah.
So this is going to be what? What am I going to write?
Negative 20a cubed x squared.
Negative 20. Now I'm multiplying 9 times this, though, right?
Yeah. Oh, wait.
So
It'll be
here, let me do it over here. 2 over a times negative 20 over 1. Oh, a to the 3rd over 1, right?
mm-hmm.
So if you want, just go straight across. What's 2 times negative 20?
Negative 40.
And then a is still on the bottom because a times 1 is a, right?
Mm-hmm.
So when I divide this, what do I get?
Negative 40 a squared.
Right. Which is what I want because I want to get an a squared, right?
I thought you wanted a x squared.
Oh, I mean, yeah. But yeah, with the x squared is going to be automatic because we're multiplying the negative 1 times the x to the 3rd. Does that make sense?
Mm-hmm.
So yeah, we do want that, but yeah, well, I guess we don't want this. But this is what it's going to be. It's a good thing because we don't want to have any third power. So this is not going to be negative 20. What's it going to be? Negative 40 a squared. Right?
Yeah.
Technically, a squared x squared. Right?
Mm-hmm.
All right. So what happens when I do this? What do I do now? What do I know about the coefficient?
Well, we usually combine like terms, right?
Yeah. So what am I combining?
You'll do 15 minus 40 and 4 plus 2 and 2 plus 2, like adding the exponents.
Well, but let's do this. This plus this is going to equal what?
Negative 25.
What's it going to equal?
Negative 20.
Right. Because see, I can't add these together. Why can't I add these together?
Cause, oh, wait, yeah.
Because one's a to the fourth
Yeah.
and one's a squared, right?
Yeah.
So what happens now is I'm just going to write 15 a to the fourth minus 40 a squared. When I put those together, it should equal negative 20 because that's the coefficient that they're telling me. Yeah?
Mm-hmm.
All right. So this is a quadratic. I think we did this together the other day. How do I solve a quadratic when it's got a fourth power?
You'll substitute it with h.
Exactly. So I'm going to write this, and I'm going to get the other thing on the other side. So it's going to be plus 20, right?
Mm-hmm.
And I notice, what do they all divide by?
5.
So this would end up being 3a to the fourth minus 8a squared plus 4, right?
Mm-hmm.
All right, so now if I replace this, it's going to be 3h squared minus 8h plus 4 equals 0. If I were to use factoring, what's 3 times 4?
12.
And then negative 8 on the bottom. And then I divide by the 3. What are two numbers that multiply to 12 and add the negative 8?
6 and 2.
Yeah, 6 and negative 2, right?
Mm-hmm.
So negative 6 plus negative 2 is negative 8, and negative 6 times negative 2 is positive 12. These are the opposite of my answers. What's h equal?
Positive 2.
Yeah. And h equals what?
Positive 2/3.
Now, that's not my answer because what's h equal to in this whole scenario?
H squared.
Or x squared, right?
Yeah.
So this is actually x squared is equal to 2. And this is actually x squared is equal to 2/3. So what are my answers going to be?
It'll be...
Well, what do I have to do to get my answers?
You have to square root it.
So x is going to equal what?
Square root of 2.
Which we're just going to leave it like that. But what's important about this?
Oh, yeah.
And what's the other one going to be?
Plus or minus square root of 2/3.
Yeah. Don't get all worried about finding out the exact numbers.
Wait, so I have a question about that. Because
Yeah.
in the last question, they didn't allow that.
What do you mean didn't allow it?
They didn't allow the... Wait, is that an answer?
Well, but that's because what is the square root of 1?
A 1?
Yeah. They're expecting you to do that. Does that make sense?
Yeah.
Now, like, I get it, but it's kind of like if you left the answer square root of 25.
Mm-hmm.
It wouldn't necessarily be wrong, but no one's really going to understand why you don't change it to a 5.
Yeah, okay.
Okay?
Uh-huh.
Now, in this case, why are they allowing us to leave it this way? Well, let's make sure they do. Yeah, because square root of 2 is not a perfect... So what's going to happen is, like you'll notice, they also would have accepted this, and they also would have accepted that. What do you think the square root of 2 is?
That, yeah.
And what do you think the square root of 2/3 is?
0.
If you would have made them decimals and then you would have rounded to 3 significant figures, they would have accepted that. Or they would have just accepted this because it's actually more precise.
Alright.
Now, also in this one, notice though that they don't give you anything if you just write those two. Okay? If you don't write those two, if you just write square root of 2 and square root of 3, you're not getting points. Actually, I take it back. It looks like they're going to just give you 1. Now, here, 2 points for the correct answers, both plus or minus. Here, they got us here for finding the terms, all 4. And normally they specify you can get 2 points, 1 point, or no points. And a lot of times what happens is that it specifies what they're looking for. And this one isn't really clear, so I don't really know how they justify or when they give you 2 and when they give you 1 and when they give you nothing. But this is worth 2 points. They could give you 1. I'm guessing if one of these had an error, then you would only get 1 point. And if all of them are right, you'll get 2. And if more than one of them has an error, then you're probably not going to get a point. But honestly, I don't know what's the difference between, like how much of a mistake you have to make and still get the 1. And see, here's the method where we try to multiply this times this. We get this quadratic. We have to get this quadratic. Somehow we need to show some kind of method for solving it to get the method point, and then we get our answers. And again, if you're not going to use factoring, you could do, the quadratic formula, but you got to make sure you write it down so you can get that method point. Okay? So take a look, because actually these are pretty common. Here, where they give a pretty straightforward one, and then they multiply it times something else, and they ask you for a particular term. I mean, this happens a lot. It also happens where there's got to be these x's in the denominator. That happens a lot. Now, in this case, like I said, this is kind of weird. This is kind of this whole p equals 6q. But sometimes there'll be a coefficient. Actually, I haven't seen this happen very often like this. Typically, it's more like this next question where there's a variable and they tell you the coefficient is equal to negative 20, and you've got to figure out for both of them and add them together and get the negative 20. In this case, it ends up being quadratic. And see here, you can see this is pretty similar. Just verbally, tell me what you would do in this one.
I would first reorganize it.
So what would this one be?
Kx plus x to the negative 1 power.
All to the 5th.
Mm-hmm.
Okay, and what's this other one going to be?
Plus 1 minus 2x to the negative 1 power to the power of 8.
All right, now, remember, what's that? What term are we looking for?
X to the negative 1 power.
Okay, so basically what that means is I need x to the negative 1 power from this one, and I need x to the negative 1 power from this one. Now, clearly, it's going to have k's in it, but when I add them together, it's going to equal 74. Yeah?
Yeah. Yeah.
All right, so then if I'm going to figure this out, I'm going to go like this. 5, choose something. This is going to be kx. This is going to be x to the negative 1. Now, what would be my equation? If this is r, let's see if I can get this right, and this is 5 minus r, when I multiply these two terms, I want to get a negative 1. So what's my equation going to be?
5 minus r equals negative 1.
5 minus r equals negative 1. And when I combine like terms, what do I get?
5 minus 2r equals negative 1.
5 minus 2r equals negative 1. And when I get the 5 and move it to the other side or subtract it, I get negative 2r is equal to what? negative 1 minus 5?
-6.
And when I divide both sides by negative 2, what's r?
3.
All right, so now if I make this a 3 and I make this a 3 and I make this 5 minus 3 or 2, okay? I got to figure out what that is, yeah?
Mm-hmm.
And it'll be some number k, x to the negative 1. Now take a look at the difference here. What's this combination going to be?
8, choose.
Something, right? Then it's going to be 1. And then it's going to be negative 2x to the negative 1, right?
Mm-hmm.
Now notice how this is different. Are there x's in both of these spots?
No.
All right. So what power do I need to raise this term to so it ends up being to the negative 1 power?
1, right?
Exactly. So, because if this is a 1, it'll be negative 1 times 1, right?
Yeah.
Now, if this is a 1, what does this one have to be?
A 7.
And then this has to be a 1. So if there's only one term with a letter, you don't have to use this whole equation thing. Because you should be able to figure out what power you have to raise it to give you the one you want to end up with. Because there's only one thing going on. Does that make sense?
Yeah.
At any rate, this will be a number, this will be a number. When I multiply them together, I'll get some number x to the negative 1. When I multiply this, will be a number. This will be k squared. Oh, k squared, right? Mm-hmm. So I'm going to get some number k squared, and that's going to equal that, right?
Right.
I'm going to add them together. So I'm going to get some number k squared plus this number. And again, we're not worried about the x, it's negative 1. And it's going to equal 74. And see, my guess is it's going to be another quadratic, which we'll have to solve. And find out what k is. I'm seeing more of this recently in this kind of question.
Yeah.
All right, so you have any problems or questions about that paper we did today in class?
Yep.
Let me see if I can find it. Come on. Oh, wrong paper. Binomial. Geometric. All right. What are we looking at?
Question number 4. Oh, no. Yeah, question number 4 in the back.
Question number 4. Okay, so what do you got for question number 4?
I have nothing. I have nothing.
Well, so what do you see? What do you think about it?
So it says that in the game of Monopoly, a player has to stay in jail until they roll doubles. So I'm assuming we're doing something with dice.
All right, we're rolling dice, right? How many dice are we rolling?
2.
All right, so what's the probability of getting doubles?
2. Wait. 2 wouldn't it be 2 out of 36, right? No.
Give me an example of doubles when you roll 2 dice.
A 5 and a 5.
What else can you get?
A 4 or a 4.
What else can you get?
A 3 and a 3.
Yeah, so let's make it easy. Can you get a 1 and a 1, and a 2 and a 2, and a 3 and a 3, and a 4 and a 4, and a 5 and a 5, and a 6 and a 6?
Yeah.
How many is that?
6.
So, how many And then how many different things can happen when I roll 2 dice?
Uh, the other things like
Yeah, anything else. How many? All the possibilities.
what do
Remember, we
you
did 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, and we found out all these numbers.
mm-hmm.
How many are there?
There's 36.
Exactly. So there are 6 out of 36 ways to get doubles. Yeah?
Oh, yeah, yeah.
All right. Now, if there are 6 out of 36 ways, what's the probability of getting doubles? Reduce it. What's 6 over 36?
Oh, one, oh, 1 6.
Yeah, right?
Mm-hmm.
All right. Now, in this situation, how long do you stay in jail?
Until they roll doubles.
All right. So this whole process stops when you roll doubles. So first, what kind of distribution is this?
It'll be geometric, right?
Exactly. Because what happens is that it stops when I get doubles. I want to know the probability of getting doubles after how many turns? I want to know the probability that x is what? More than 3. How do I write that?
It'll be greater than 3, right? X is less than 3.
It'll be greater than 3, right?
Yeah, greater than 3. Yeah.
Okay. Now, do I have a formula for that?
Yeah.
I do. What is the formula?
Q to the power of R.
So, if this is P, what's Q?
Would it be 3? Or no?
If the power of something happening is 1/6, then what's the power of something not happening?
5 6.
Exactly. Because they have to add up to 1 when I add them together. Isn't that right?
Yeah.
So what I'm going to do is I'm going to do the power of failure 6 times. Oh, wait. How many times?
3.
There you go. What do you get?
125 over 216.
125 over 216. Take a look at number 5. Can you do that one?
I'll try.
Hopewell, a basketball player, makes 80% of his free throw shots. You have him shoot free throws until he misses one. What's the probability that he makes more than 3? All right, now what are we interested in?
No, the probability that he'll succeed.
No. What are we interested in?
Where he makes more than 3. When until he misses 1.
That's what we're talking about, right?
Mm-hmm.
That's what I need to know the probability. If the probability of him making shots is 80%, what's the probability of him missing shots?
20%.
So, is this a binomial or a geometric distribution?
It'll be geometric, right?
Because what happens is that we don't know how many shots he's going to take, but we know when he misses one, he stops. Does that make sense?
Mm-hmm.
But the thing is, in this case, I need to know what the probability of the miss is. So the miss is going to be 0.2, right?
Mm-hmm.
All right, now, like you said, let's write down the probability. I want to find out the probability that he makes more than 3. So I want to find out the probability that the x is greater than 3. Is that right?
Yeah.
All right, so what can I do with that one?
You can use a formula, and which is q to the power of I.
Exactly. And what's q in this case?
It would be 0.8, right?
Exactly. And see why it's important to write this down? This tells me the probability of a thing I'm interested in. I know it seems weird, but the thing that only happens once is that he misses. That's the thing I'm interested in. In a geometric distribution, the thing I'm interested in is only going to happen once. So now that I've written this, then it should be really clear that the probability of failure is going to be 0.8. But it'll be to the third.
So what does like back to the first page, what does P and Q represent? P represents the
Probability of success,
right.
which don't think of that as being good or bad. Think of P being the probability of a thing you're interested in. Technically, Q stands for the probability of failure, but again, that has negative and negative connotations. It doesn't have anything to do about missing or making. It has to do with not being interested in it. So look at number 6. Either a toy boat, a car, or a plane is equally and randomly placed in these cereal boxes. You purchase 5 boxes of cereal. What's the probability that you get more than 3 cars as prizes? What are you interested in?
The 3 cars as prices.
I want to know the probability of getting a car. What's the probability of getting a car? If there is a boat, a car, and a plane, all equally and randomly placed in boxes.
It would be 1/3, right?
Exactly. So in this case, P, the thing I'm interested in, is 1/3. Now, what kind of distribution is this?
It would be binomial, right? Because it's just
You'll notice how there's a set number of trials, and what's more, there's the thing I'm interested in happens more than once. It doesn't happen and then stop. Okay? So, this is a binomial distribution where the number of trials is what?
5.
And the probability of success is 1/3. Now, I want to find the probability that x is greater than 3. Now, in this case, if there are only 5, that means, what does that mean in words? That means out of the 5 boxes of cereals, how many of them are going to have a car? Does it mean 3 could have a car?
No, it's more than 3.
So, and keep in mind, there are boxes of cereal. So if it's not 3, it's got to be 4, right? And if it's not 4, it's got to be
5.
And why can't it be more than 5?
Because there's only 5 boxes.
Because I only got 5 boxes of cereal, right? So I've got to find the probability of 4 and the probability of 5 and add them together. How do I find the probability of 4? What goes on the top?
4 to choose.
Yeah, what goes on the top of my choose?
4,
How many boxes did I get?
5.
The number of trials always goes on top.
Okay, so
Okay.
5. Yeah.
Now, the number that I'm talking about, in this case 4, goes on the bottom. What's the probability of success?
1/3.
What's the probability of failure?
4/3.
4/3.
Well, no, 3/3. No, 3. Wait, 2/3 on that.
Yeah, right. 2/3. Right. Okay. Now, in this one, these two have the same number. If this is 4, what's this?
That's 1.
And then this has to be 1. Right?
Mm-hmm.
All right. Now, I want you to think about this. What's the probability of success getting a car?
1/3.
1/3. If I want to know the probability of getting 4 cars, then don't I have to do 1/3 times 1/3 times 1/3 times 1/3?
Mm-hmm.
Then what happens is that after I do that, then there's one time that I don't get a car because I'm only getting 4 cars, right?
Mm-hmm.
So then this last one will be the failure. Does that make sense?
Oh, yeah, okay, yeah.
All right, so now take a look here. Now, if I talk about the probability of X equaling 5 cars. Well, now I have 5 choose 5. This is going to be 1/3. Now, again, think about it. This is a success. If I want to get 5 successes, how many times do I have to do this? Times itself 5 times, right?
Right.
And if I want to have 5 out of 5 cars, that means I can have no failures. Yeah?
Mm-hmm.
And see, this is a number, and this is a number, and all you do is add them up. Take a look at number 7. What's number 7 say?
It says that a computer chip company rejects 2% of the chips produced because they fail pre-sold testing. Part A says, was a probability that the first defective chip you find is one of the first 5 that you check.
All right, so think about it. What am I interested in?
The probability that the first...
What am I focused on?
The defective chip.
Exactly. Is that the probability they gave me?
Mm-hmm.
All right, so that's P, right?
Yeah.
All right, now, you want to find the probability that the first defective chip is in the first 5. So what distribution am I talking about?
Ooh,
Is it binomial or geometric?
Be binomial, right? Because there's a limit.
Well, but the thing is, what am I finding?
The defective chip.
Which one?
Oh, the first. Oh, okay.
Do you see I'm only noticed it? I'm only, because let's face it, out of 5, could I possibly get 5 defective chips?
Mm-hmm.
Could I get 4?
Yeah.
Could I get 3?
Mm-hmm.
But it's not asking me for a number. They're asking me when I get the first one. That could be on the first one I look at, the second one I look at, the third one I look at, the fourth one I look at. But at the end of the day, to answer this question, I'm only going to have 1 defective chip. This is geometric. Because they're talking about what's the probability of getting the first one. And again, the probability is 0.02 because that's what it is to get a defective chip, right? So when I write my probability statement, I want to find the probability that it's one of the first 5. What does that mean? Or how do I write that in math? One of the first 5. Is that less than 5? Clearly it has to have a 5, right?
Yeah.
Is it less than 5?
It's less than 5.
It's one of the first 5. Does that mean it could be the 5th one?
Yeah.
So that means really it's this, right?
Less than or equal to.
Yeah?
Mm-hmm.
All right, now, do I have a formula for this?
Yes, you do.
I do. What is it?
1 minus q to the power of r.
So what's Q?
Q would be the point 98, right?
Right. And what's R?
5.
And see, all I got to do is that.
Boy. I gotta memorize like.
Well,
or,
there's
like,
again, there's only 3 formulas, but you do got to memorize them. Now take a look at part B. What's it say?
What is the probability that 3 of the 20 chips checked are defective?
All right. So what's this distribution?
That'll be binomial, right? Because it's
Exactly. Because how many are we talking about?
20 chips.
And what's the probability of success? But what I want to know is what? The probability that what?
3 out of the 20 chips are
Okay,
defective.
now, it doesn't mean it's the first 3. It doesn't mean it's the last 3. Some 3 somewhere in the 20. Does that make sense?
Mm-hmm.
All right. So how do I figure this out?
You set it up.
What am I going to write down?
20 choose 3.
Because in this case, that's the only one I'm interested in, right?
Mm-hmm.
And then what do I put next?
The probability of success.
And again, think about it. If 0.02 is a success and I'm interested in having it 3 times, it's going to be 0.02 times 0.02 times 0.02, or to the 3rd power, right?
Right.
Now, what's the probability of failure? That means not getting a defective.
0.98.
0.98. Now, again, out of the 20, that's 0.98 times 0.98 times 0.98. How many times am I going to multiply 0.98 times itself?
17.
Because together I need to have 20 chips, 3 of them good and 17 of them bad. Because this is very specific. They only wanted the probability of finding 3 out of the 20. And see, all I got to do is figure out what that number is.
Yeah. I think like I just gotta. You know how you said you gotta. How it's good to reward what you're doing so you understand what you're doing.
Yeah.
That's what I'm doing. Because I get like what you're doing, but I have to explain it. Like you get what I mean?
Yeah. Oh, definitely. You got to rethink it. You got to put it in a way you're going to remember it, right?
Exactly. So for the quiz, like, what should I do to prepare, or
Well,
and as
you
well as
got
for
these
the
papers, right? You got a paper on probability distribution.
yeah.
You got a paper on binomial, and you got a paper on geometric and binomial.
Mm-hmm.
I mean, anything that's going to be on that quiz is going to be if it's stuff you have to do on these papers.
So, is this sheet? When is this sheet gonna be due?
Good question. I don't know. I don't know. Maybe I'll make it do. I don't know. I mean, that's a good question. Because we went over that test today, we didn't get as much time. I want you to try to get it done, but maybe I won't make it due on Thursday. Maybe I'll make it due on Thursday night or something like that. So that way, if you got questions about it, we can talk about it in class.
Yeah, because I plan on working on it today, and like if I get stuck, I just want to ask you in tutoring.
Yeah, that's fine. Take a look at number 8. What's it say?
Only about 4% of people have blood type AB.
On the average, how many people would you expect to have this blood type? No, I worded that wrong. So let me do this again. On the average, how many people would you have to check before you find someone with this type? So how many people am I going to find with this type?
4%.
No. I'm checking people. I'm checking people. When do I stop checking?
Oh, is this like an infinite amount? Or?
No. Because when am I going to stop? It says, how many people would I have to check to find someone with this type?
Oh,
So I'm checking. Are you this type? No. Keep going. Are you this type? No. Checking. Are you this type? No. The next person. Are you this type? And then they say yes. And see, that's the probability. They want me to find out how long it's going to take me, or not in this case, how long is it going to take me to find the first person to say yes to that question? So is that a binomial or a geometric?
it would be a geometric, right? Because there could be an indefinite.
And average is the same thing as mean, and mean is the same thing as expected value. How do you find the expected value for a geometric distribution?
Ooh, you do 1 divided by p.
And so in this case, it's 1 divided by 0.04. What's 1 divided by 0.04?
25.
Now, look at this one. On the average, if you checked 20 people, how many would you expect to have this blood type? Now, notice in this case, and again, this probably should be worded a little bit better.
Mm-hmm.
How many people before you find the first person with this type? That should be number 8. In the second one, it just says how many out of 20 would you expect? What kind of distribution is this?
That would be binomial, right?
And this is a binomial, okay?
Right.
Now, in this case, and 20 is the, right? Okay? And P is 0.04.
Mm-hmm.
So how do I find the expected value of a binomial distribution?
Oh, you do n times p.
Exactly. What's n times P? Well, it's 20 times 0.04. And if you think about it, that even makes sense. How about this? If I was gonna flip a coin 20 times, how many times would you expect it to get heads?
You'll do 1/2 times 20.
Which is
10.
10. Now that makes sense, doesn't it?
Yeah, that makes sense.
Well, this is the same kind of probability. I'm checking 20 times, and the probability of it happening is 0.04. So the expected, my mean or my average is going to be 20 times 0.04. Take a look at number 9. 8% of males are colorblind. What's the probability that of the first 5 men checked, none are colorblind? Now think about it. A geometric distribution is when I want to find the first. Take a look at B now. What is the probability that the first colorblind man found is the 6th one checked? What's the distribution for B?
It will be geometric.
That one's going to be a geometric. Okay?
Yeah.
Now, this one's going to be binomial. Because you notice how I'm checking all the men. I'm not stopping when I get one. I'm checking all the men. And I want to find out the probability of either, in this case, I want to find out the probability that x equals 0, which means that none of them have it. So this is binomial. Oops, did that backwards. X binomial. What's my sample size?
5.
And the probability is 0.08. in this case, I want to find the probability that if I check all 5, none of them are colorblind. So that's going to be 5, choose 0, 0.08. Now again, think about it. If I want to have 0 successes, how many times do I multiply 0.08 times itself?
5? Oh no, 0. Yeah.
And that means that out of the 5, they all have to be failures, meaning they're not colorblind. So that means that has to happen 5 times. 0.92 times 0.92 times blah, 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 right?
Mm-hmm.
This is going to be 1. This is going to be 1. I mean, that's going to be the answer. All right. How's that? Is that a little bit better?
Yeah, that does sound a little better. I'm gonna redo these problems, like try and understand it.
Try to redo them. Like I said, just keep in mind, if you focus on what a geometric is, and the fact that a geometric, it's gonna be the first. It only is ever gonna have one success.
Mm-hmm.
Anyway, thanks for coming in today. See what you can do with this. Send me an email. Like I said, what I'll do is I'll make it due on Thursday night. And so that way, if there's questions about it, if there's a couple you can't do, then we'll just, we'll talk about it in class after the quiz.
All right. So for the quiz, I should just go over the papers that you gave us?
I'm telling you, I mean, if it's not on these papers, it's not going to be on the quiz.
Okay.
All right?
And
again, you'll notice that I get it. There's a lot of problems here, but there are a lot of similar problems.
Mm-hmm.
There's not a lot of different problems. But go back and look at that probability distribution table one. And then look at the other one, the binomial, which is mostly binomial. And like I said, look at these geometric ones. But this is the stuff you're going to have to be able to do.
All right.
Cool?
Yeah, and I was gonna ask you about the test. I wanted to go. So, for the test on Monday,
Yeah.
is it also gonna include combinations and permutations?
Yeah.
Okay. Yeah. Okay.
Well, let's see. My plan was to do the Thursday thing on combinations and permutations. But see,
Okay.
all anyone was interested in was doing the other stuff. So now I'm not sure what I'm going to do on Thursday.
Yeah, cause I wanted to I took pictures of my test so I could redo some of the questions see if I could do it. And wait, so Thursday, do you have an idea of what's tutor gonna look like, or no?
No, like I said, I'm kind of thrown right now because, like I said, my plan was to do it because what's going to happen is we'll take the quiz in the beginning of class,
Uh-huh.
and then we'll go over it,
Mm-hmm.
and then they'll give you some problems to work on from the textbook that is going to be, binomial distribution, geometric distribution, and then probability distribution to practice. Okay? And so I figure we'll be practicing the binomial and the distribution and the geometric pretty heavily. And then I would do the review thing with permutations.
Okay, yeah, that does sound good. Yeah.
And so my plan was to spend more time on it. But what I may do is try to divvy it up a little bit. Maybe, like I said, I may try to mix it up a little bit, but we'll see. But that was my thinking originally, was that in class we would have spent a lot of time talking about, the other ones.
Mm-hmm.
And so the review session was going to be over permutations and combinations. I was going to be focusing on that.
You think you could because I wanted to go over my test, right? You think you could go over some questions that were on the past test?
Yeah, sure.
Yeah, all right. Because I want to see how to do it.
Yeah, try to do it, and then we'll look at it on Thursday.
All right. That sounds good.
All right, man. Have a great one.
Thank you, Mr. Cross.
Have a good. Bye.